In this video, we are going to continue working on right triangle trigonometric ratios. Let's record. In a right triangle, we know that angles have a sum of 180 degrees. And that two acute angles are complementary. Complementary means 90 degrees. Since we have 190 degrees, other two things must be together 90 degrees, right? Complementary. So let's see. Example 6. Notations. Degree is all missed here. So can you put degree notations for 90 degrees, 180 degrees here, and this is Greek letter theta. You can write theta like this or a little bit slanted and horizontal line like that, okay? That's theta. Greek letter theta stands for angle in math class. So find sine, cosine, and tangent ratio for each acute angles. So what acute angle do you see in a triangle ABC? A is acute and B is acute, right? All right. Triangle ABC has 90-degree angle, and we have 6, 8, 10 as length of sides. And the other triangle, DEF, has 3, 4, 5 as length of the sides. Are they similar to each other? Triangle ABC is similar to triangle DEF. Why? How do you know? All angles are congruent. That's right. AA, triangle similarity. Or you can say the ratio. What is the ratio of two sides? Yeah, 1, 2 to 1, right? 2 to 1, 2 to 1. So one is enlargement, the other is reduction, right? So they are dilation. So we can go with side, 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 triangle similarity. So they are similar. So in this practice problem, we are going to see ratios are same, okay? So let's go with sine A. What is sine A? What is cosine A? What is tangent A? That's the question. Find sine, cosine, tangent for each acute angle. Angle A here. And then angle B. What is sine B? What is cosine B? What is tangent B? And in a small triangle, I have two acute angles. What are they? D and E, right? So I need to find sine D, cosine D, tangent D. And one more, sine E, cosine E, and tangent E. So we are going to use the angle measure, okay? If by switching the angle, sine and cosine will be swapped. That is what you are trying to find it, okay, as a pattern. All right, so let's see. What is sine A? Opposite side, that is 8. 8 over longest, 10. Can you reduce? 4/5, right? Okay. Cosine A, don't use 8 or 10. Start with a 6. Same hypotenuse. Can you reduce? Yes, 3/5. Tangent, start with the first number 8 over 6. So this will be 4/3. Right? Okay, now let's change the angle. We are now looking at theta angle from A. Let's look at 90 degrees. Subtract theta degrees. That is complementary angle to angle A. So we are using angle B. So this is angle B, which is opposite from angle B, number 6. So this will be 6/10, which is 3/5. The third number we didn't use is 8. So I need to do 8 divided by 10, which is 4/5. Tangent B, first number 6 over 8, and which is 3/4. So by looking at this, you can see these are the same numbers from different angle, switch sine and cosine. Switch sine and cosine, then these are the same number for different trig. So sine, cosine swapped, angles are swapped, we have the same numbers. Okay? All right, now let's do sine D. Sine D, what do we get? D is the angle, so this is 4/5, 3/5, 4/3. Are they same thing from the first set? Yes, they are, because trig ratios are all same in similar triangles. Okay, that's why you have a trig chart with all ratios. That is in your calculator also. Okay. All right, now let's finish sine E, cosine E, tangent E. By switching angle, opposite side will be swapped. So this will be 3/5, and next one is 4/5, and tangent is 3/4. So this ratio is same as the ratio from the similar triangle, okay? So that is what we observed. A trig function of a complement of an angle is called a cofunction. Okay, cofunction. Sine and cosine are cofunctions. Co stands for complementary, okay? Cosine, okay. So number 7, can you write trig functions in terms of its cofunction? So the question has sine and I need to answer with cosine. What's the number? So let's do numbers. 90, subtract 42. What do I get? 48? 48 degrees. That's called cofunction. Okay. All right. Now let's do the next one. Cosine 36 degrees. What is cofunction? Instead of writing cosine, I need to use sine function. So 36, what is complementary to 36? 54 degrees. That's right. Next, cosine 51 degrees. What is cofunction? Sine 39 degrees. So we are making sum of 90 degrees, okay? So we are subtracting this number from 90 degrees. Last one, sine 28 degree is equal to cosine 62 degrees, okay? They have the same ratio. You switch angles in complementary angles and you switch sine and cosine, the values are exactly same. So this can be written as formula. All right, this is the formula. Can you understand the notation? Sine theta degrees is equal to cosine, parentheses, 90 degrees subtract theta degrees. So we are talking about complementary angles. Does it make sense? Okay. You don't need to memorize this as formula, but you need to understand this idea. Okay, so you need to understand this idea, okay? And let's look at the next one. What is the meaning of this? Theta degrees, that's angle. 90 degrees minus theta means complementary angles. So that tells us 1 over something, that means reciprocal. So let's see, what is the tangent A here for thirds? What is tangent B here? 3/4. Is it flipped? Yes, that's called reciprocal, okay? So to describe reciprocal, we write this way. Tangent theta is 1 over, that means flip. Flip is complementary with the tangent, okay? So this is called identity in pre-calculus class. And this is how we write the formula or equation, always true. So this is fact. Okay, so don't worry about writing this and understanding the notations at this point, but you need to understand or highlighted part. These are the same when we swap angles A and B. Sine goes to cosine, cosine goes to sine. When we swap the angles in tangent, you take the reciprocal, flip the number to get the same answer. That's the formula here, okay? The formula is called identity in the future later. So let's see. What is cosine 90 degrees subtract theta, knowing that sine theta is 2/3? Did we switch sine cosine? Yes. Did we switch theta and 90 degree minus theta? Angles are swapped. So answer will be same as it is. Next one, cosine theta is 4/5. Sine complementary angle. What would be the ratio of sine with its complementary? Same answer, right? Okay. Next question. We have tangent theta. We want to change the angle to complementary angle. What would be the answer? Is it going to be same answer? No, it means 1 over something, right? So this is reciprocal. So let's flip the number. What do we get? 3 over 2. Okay, flip the number, reciprocal. Last one, tangent theta is given 1/5. What is the tangent value of its complementary angle? Flip the number, so this will be 5/8. So we talk about formulas, identities, or equations, and we use the formula to find the angle with its ratio by using trig identities.